Great. Yeah, we're going to get started in a few minutes. Let me share my screen here. All right. Welcome. It looks like we've got a lot of people joining, so welcome. We're going to be getting started probably at about 2:02, so we'll give ourselves a couple more minutes. All right, it looks like we've got about 20 or 25 people here, so good crowd. I appreciate everyone joining. As we've talked about, or as you know, we're going to be demonstrating some Kubernetes hacking techniques and really ultimately some security techniques today. We'll still give people a couple more minutes to join though, just because I don't know if everyone will be here exactly at 2. Yeah, so we'll give everyone a couple more minutes. Can everyone see my screen? All right, great, good deal, John. You know, I'll go ahead and get started now, but I'll do a bit of an intro before we get going. So welcome. My name is Jacob Beasley. I am one of the co-founders of Minesweeper and of Intellitive Consulting. We're a Kubernetes/DevOps consulting firm based out of Minneapolis. My business partner Jason and I founded the company and have been between us doing DevOps and SRE work for 30 plus years in combined experience. So for many years. We have a team of very talented people. And this past kind of couple of years during COVID-19, our COVID-19 project was to learn a lot about Kubernetes and Kubernetes security. And so out of that comes this presentation kind of teaching about Kubernetes security. I started doing computers when I was young, and I wanted to learn how to break things, and then I learned how to put them back together again. So I love this style of teaching where I'm going to kind of explain to you the nuts and bolts of how Kubernetes works and how someone might break Kubernetes, right? How they might hack into Kubernetes. And then from there, I'm going to show you how to build it up, how to prevent a hack, because I think once you understand how someone might take advantage of Kubernetes, then it makes the concept of securing Kubernetes much more intuitive. So without further ado, I think we can get started. So agenda, here's what we're going to cover today. First of all, we're going to give you some background about what Kubernetes is and how it works under the hood. We'll talk about the 4 C's of Kubernetes security. And we'll also talk about what a reverse shell is, because before we start diving in and actually basically breaking into Kubernetes, we're going to be actually teaching you a bit about what the nature of the attack is and how it works. I know some folks joining probably have not used Kubernetes very much. So that's why we're starting from 0, maybe review if you're already a Kubernetes expert. But if you're not, I want to make this accessible to anyone from the IT community. So first of all, Kubernetes is what we call, this is from their website, an open source container orchestration system for automating computer application deployment, scaling, and management, which is probably very confusing if you read the dictionary definition. So here's what I like to say. It's like an operating system for your data center. It gives you the batteries that you need to deploy your software on one or more servers. So think of like an operating system for your data center. You package up your software in these things called container images. And then when you deploy that container image, that's called a container. So with Kubernetes, you basically say deploy these applications, they call it a pod, deploy these containers with this configuration, and then it makes it so. So theoretically, you could have hundreds or thousands of servers, and you could say deploy 50 of this application, 10 of that application, 3 of this application, and it'll take care of things like load balancing and log aggregation and other kinds of things, access control, failovers, monitoring, all of that for you. It'll figure out which servers should run which applications. It's very powerful. At this point, it's become the dominant system for deploying containerized applications. And it seems as if containerization and containerized applications are becoming the predominant way that custom software and even non-custom software is going to be deployed probably in the 2020s onward, right? It's quickly gaining popularity. What is a container? So this is important because if you don't understand this, you'll probably be fairly confused about the nuts and bolts of what Kubernetes is. So a container combines your code, the operating system, and any dependencies that your code requires. So you might say, I'm going to start with Debian Linux, and then I'm going to add on the Java virtual machine, and then I'm going to package on my application code or my compiled code. Or you might start with Debian Linux, add on Node.js, and then add on your JavaScript code to deploy and run your JavaScript code. You define this process of building your container image in typically a Docker file. There are other technologies, but people will use Docker or Podman to do this. It produces ultimately a container image, which then can be deployed and run. And it basically, at a very high level, when you deploy a container image, it basically unzips the image and runs whatever command you tell it to run when it boots up. There's more to it than that, but if you can think of a Docker file or of a container image, a lot like a zip file or a tarball with a bunch of files in it, that's ultimately what comes out of it. There's layering and there's other things, but if you think of it like that, it probably will make a lot of sense to you. What are the key parts of a cluster? This is important because when we talk about how to exploit Kubernetes, you also have to understand a bit about how Kubernetes works. So the first thing to understand is there's kind of two parts to a Kubernetes cluster. There's the control plane and the workers. And the control plane is what says what should be done. And so there's this service called Kubernetes API or Kube API. And its job is to keep track of what needs to be deployed and where it should be deployed. There's various other supporting services that it uses to do this, but all you really need to know is Kube API is in charge of deciding what should be deployed and where. And then there are a number of worker servers who then talk to Kube API and say, what am I supposed to be running? And so the application running on each worker is called kubelet, and it simply reaches out to Kube API regularly and says, what am I supposed to run? And then it makes it so. It will actually use Docker or Containerd to basically run the containers. So that's basically how Kubernetes works. Those are the key parts. When we think about containerized applications and container securities, there's 4 things you need to think about. And we're going to talk, but I'm only really going to focus on 2 of them because a couple of them really are not Kubernetes specific. At the most bottom layer, you have your code. So the applications you're deploying. And if those have major vulnerabilities, you might get hacked, right? Above that, you've got a container, and that's again our operating system. When it gets deployed, it unzips our code and all of its dependencies, which include operating system utilities, operating system libraries, and our code, and it runs our code. But the container is a layer of security around your applications. In theory, different containers should be isolated. As you're going to see, if you're not careful, they're not actually isolated, but the container is that next layer. Then you've got the cluster, which in this case would be Kubernetes. Kubernetes is in charge of keeping track of what should be deployed where. If you can tell Kubernetes to deploy bad things, then you can take advantage of the infrastructure. And finally, you have the cloud, which we're not going to cover too much, but think of that cloud layer as Amazon Web Services, Google Web Services, might be something like VMware if you're on premise. That cloud can deploy servers. And again, the cloud is not very Kubernetes specific. So we're going to mainly be just talking about Kubernetes and the container, because those are really the parts that are unique to Kubernetes. There's a lot written and a lot of knowledge out there about how to make code secure, and a lot of knowledge about how to secure your cloud using 2-factor authentication and access control and virus scanning and all of that. Really, the cluster and the container is what's unique to Kubernetes and really what is within scope of this presentation. Before we begin, I feel obligated to tell you that you can do these things on your computer like I'm doing them, but you shouldn't be doing them against someone else's servers, right? And even if you're in a job environment, if you make applications do things that were not intended to do, that can be a violation of the Computer Fraud and Abuse Act. So even if you're a penetration tester and you want to use these, and you're hired to do penetration testing and you want to use these things, these techniques in that environment, you have to make sure you've been hired, you have access to those servers legally, and you have to comply with whatever privacy laws are in place. So if it's HIPAA data, that's healthcare data, or PCI credit card data, even if you're doing pen testing, you still have to comply with privacy regulations. So be careful. It's not a big issue, but I just want to make sure people are aware of that. The reason I'm sharing this is I'm hoping people build a awareness and knowledge of Kubernetes security. I also want to mention that I'm not trying to scare you, right? Because Kubernetes can be run extremely securely. Any other tool that you use to deploy software could have similar issues and vulnerabilities. You could be using VMware, you could be using AWS, somebody could steal your credentials and deploy bad things, right? That Kubernetes is not unique in that manner, but it is a new tool. And I think a lot of people do not know a lot about how to secure a Kubernetes cluster, nor about some of the things that can go wrong. And so I'm hoping that after you watch this, you're going to look at this and say, and you're gonna have some learnings and good things that you can do, right? All right. Final overview topic before we dive into the demo, I want to talk about reverse shells. So what reverse shells are a way for us to control a remote computer. And if you've ever used SSH or other technologies or remote desktop, you're probably familiar with being able to log into a remote server. The big difference between a reverse shell and just a normal login is that in a reverse shell, you aren't reaching out to that computer and then logging into it and authorizing the way that you would normally authorize to access the computer. With the reverse shell, you somehow execute code on the remote machine and turn it into effectively a zombie that can be remote controlled. And that's going to make a lot of sense in a minute, because in a minute here, I'm going to show you, demonstrate on my computer how that would happen. But basically with reverse shell, the computer that's hacked reaches out to, I'm calling it the wizard, reaches out to the internet and says, hey, what should I do? And then the wizard, if you will, can execute arbitrary commands as if they're logged into that server, as if they're a user operating on that computer. Let me demonstrate what that looks like. So what I've got here, I've got two different command shells open, and I'm going to basically demonstrate some techniques side by side here. Let me just size these up in a really nice, clean way. So on the left, I'm going to pretend, this one's a pretend one here. On the left, I'm going to pretend this is the client. So this could be Kubernetes, Docker, somebody else's computer. On the right, I'm going to be the kind of the hacker, if you will, right? The first step in launching a reverse shell is I have to boot up. I have to run the command to listen, to allow others to connect to me. So as the kind of hacker, I would run and boot up the reverse shell command. Let me get that. I've got it saved right here on my computer. Okay. Netcat NVLP 555. So what this one does here is it would essentially listen for incoming connections. So Netcat is a tool for interacting with networks, and this listens for incoming connections. Then on the remote computer, I would have to run a command. In this case, I'm running a shell terminal, and I'm piping the input and output of the terminal to the wizard, to the remote computer, to the hacker. I'm running this one locally. I'm going to do it in Docker and Kubernetes after this, but I'm just demonstrating it on my local computer because I think it makes more sense that way. So I'm running this, for some reason that did not work. Great. Dev TCP IP. Great. It will work when I run in Docker and Kubernetes, but I don't think. Oh, you know what? I don't have the whole command here. Yeah, it'll work when I run it in Kubernetes, but what I'm going to do is connect here. And when I run that command, actually, you know what? I think I might be able to do this. It's really meant to be run inside of Linux, and I'm on Mac. So there's a different command on Mac, and I don't have that handy with me, but that's fine. It would allow me to remote control a computer. I'm going to do this now with Docker. So I've got Docker running on my computer, and with Docker, it's basically the same command, except I'm using Docker to run that command. So Docker run, in this case, I've got Kali Linux, which is, if you know what that is, that's basically a Linux distribution that comes with a number of security tools. So things like port scanners and Metasploit to execute exploits. And then I'm going to basically run this remote terminal. And so I've got that command ready here. Okay. Oh, and you see here on my screen on the right here, when I ran that command, it connected to the one on the right, and I'm now able to execute commands inside of the Docker container. So let me just review that again. So with Docker, what I've done is I've told Docker to execute a remote shell, and upon doing so, I can now control that remote computer, listing files, doing whatever it is I want to do on that remote computer. Now, this looks pretty basic, right? What's concerning about it? Well, there's a few things that are concerning about Docker from a security standpoint. The first is that it's actually an API. So it actually runs a web server that accepts inbound connections. Normally, it's firewalled off where a remote computer cannot connect to it. But theoretically, if you have Docker running, anything that can open a socket and connect to Docker on your computer can effectively call those APIs and run a remote shell. They can even run a remote shell as root. So if you're running Docker on your computer and it's not properly firewalled off, or you're running it on a server, maybe in a Kubernetes cluster, then someone could basically connect to those APIs and execute a remote shell, a reverse shell, allowing a hacker to control your machine. So Docker is a bit concerning, and it's something that a lot of people are using. If you're running Kubernetes with Docker and you've taken the defaults, you might have it might actually be accessible. If you have no firewalls or anything, it might be accessible, and someone might simply be able to connect to that port. I have an example in the PowerPoint here where if I set the Docker host environment variable to a remote IP address, I could connect to that IP and try to execute commands. The default with Docker is to have it firewalled off, but you should check it. It might not actually be firewalled off. Additionally, again, if I'm running something else on that computer that doesn't have escalated privileges, I could use Docker to escalate my privileges. So that's another concern. So now in this case, when I run inside of Docker, there's a question here. That's the reason it didn't work. Yeah. So this works here because it's a Linux command. And when I run it in Docker, it's actually running in a Linux virtual machine instead of my Mac shell. And the command I had, there's a different one you can use for Mac. I just don't have it handy. But for Linux, this is the command you would run. So that's a good question. And you could boot up Kali, you could boot up Debian, whatever Linux distribution you want this way. So if you have access, if you're running Docker on a remote server, you probably shouldn't do that. Let's talk about Kubernetes next. So we just looked at Docker, and most people who are using Kubernetes currently are using Docker to run everything inside of Kubernetes. It should be noted that Kubernetes doesn't recommend this anymore. They actually allow you to run things without Docker, and I'll explain that in more detail later. But Docker or no Docker, if someone has access to deploy things to Kubernetes, and if you've given them free reign to deploy anything they want, which from what I've seen in a lot of environments, they have no controls on what developers can deploy, then that person can deploy a remote shell as well. The most common concern here would be if a software developer's machine was compromised, maybe through installing computer viruses or a phishing attack, and you were to then gain access to Kubernetes that way, you could use this kubectl run command to basically boot up a remote shell, in this example as root, and do anything you want on that computer, which is obviously not very nice. Can you explain that command? So say, Sachin, was that the Kubernetes command here or the Docker command that you'd like explained? I can break them down in more detail. Let me go back to the Docker one. So if you haven't used the Docker much before, Docker is a command line utility and an API for deploying software. What I'm telling you here is Docker run Kali Linux Kali. So Kali Linux Kali is the name of the container image to run. So it'll actually automatically download that Kali Linux container image, which if you know anything, you know that's all the tools a hacker would need. It's like a complete tool set for a hacker to break into other things. So not very good. And then you can pass in a command to run. In this case, I'm saying start up the bash command shell and run this command. And then I'm starting up a bash command shell and running that same command that says bash, take your input and output from, so it takes input from a remote shell. So it's going to connect to a remote computer. And it's going to basically send the output back to that remote computer. So that's what that command does. So I'm telling Docker, I'm saying Docker run Kali Linux, download and run Kali Linux, and then execute a remote shell. So that's what this command does. And for Kubernetes, there's a very similar command, same thing, but I'm telling Kubernetes, hey, Kubernetes run Ubuntu. So run they call it a pod, but boot up an application named Ubuntu using the image named Ubuntu. And then I'm going to execute that remote shell command again. So -- command -- This is a one-line command. And if I was to have enough access to deploy something on Kubernetes, and if they didn't have any limitations on what I could deploy, which we'll get to that in a minute, there are ways to prevent someone from doing this, I could theoretically deploy a remote shell. Let me demonstrate that next. Before I do that, I'm just going to kill this remote shell. There. Remote shell killed. I'm going to listen again on the right here. Okay. You get that command. So this is a big long one. I plugged in my IP. Now I'm using a local computer's IP. That's why it's 192.168. But there's no reason this couldn't be a virtual machine that I perhaps purchased on Amazon Web Services, maybe free tier, so that it's, no credit card on file. That's how someone would probably run this. So I booted up the pod, and you'll see there, now I have access. You'll see root add Ubuntu. So it's running as root. If I do kubectl get pods, you'll see I'm now running this Ubuntu. I can describe it. And you'll see that it booted up, it downloaded the Ubuntu image, and it booted it up, and it's running the command that I asked it to run. So let me explain that command carefully, because I know not everyone's used Kubernetes. So Kubernetes is also built on APIs. And whenever you connect to Kubernetes, you connect to that remote computer and you execute APIs. And kubectl or kubectl or kubectl, if you like to be obnoxious, kubectl allows you to use a command line utility to basically make remote procedure calls or to execute APIs against Kubernetes. So kubectl run is a shortcut for booting up a pod or running an application. And it accepts kubectl run Ubuntu, and Ubuntu becomes the name of that application or the name of the pod. I can then tell it what container image to run, and it will automatically download it off from Docker Hub, which is a website that has free Docker images available. And I told it to run the latest Ubuntu image. I chose Ubuntu because it comes with a lot of utilities, which is handy when I want to break out of a container, which I'll demonstrate in a minute. And then I'm executing a command, and that command again is that same bash command. And I use the syntax where I use bin bash -c because it's easy to get the formatting right, but you don't have to do it this way. This is just the way that I found the easiest to get the formatting right. But now you can see on the right here, if I expand this a little bit and make it a little bigger, I am now logged into the Kubernetes cluster as a root user. And you can see, who am I? Root. So I have a lot of privileges in that cluster. And the question becomes, if I was going to start causing trouble, what kinds of things might I do? Here's a few ideas. You could start port scanning. So if I was to run Kali Linux, I could run nmap and I could start port scanning to see what other things are running on the network. Potentially then detecting what applications are running and then exploiting them by running exploits against each one. Another thing I could do is I could break out of the container and start looking at other applications running at the server. I might be able to begin listening in on their traffic or just otherwise causing problems, right? And getting out of the container, which you're not supposed to be able to do, getting out of the container into the parent operating system is called container breakout. And I'm going to demonstrate how to do that. There's kind of 5 steps that someone would probably do. First, they'd open a remote shell. We already did that. Then they'd have to, well, you don't have to do this, but I'm going to install a text editor for myself to make my life easier as I have to run some scripts. Then there's basically you have to issue commands against a Linux kernel. Yeah, somebody says, Ismail says, always install Vim, yes. So, and then I need to execute a script that basically makes Linux kernel commands that normal users cannot do, but remember, I'm running as root right now. So a root user can do. And I'm going to execute commands using Perl to do that, a Perl script that will basically allow me it'll basically let me break out of the container I'm going to basically change the root directory from my container out into the parent operating system, effectively making me a root user in the parent operating system, which would let me do pretty much anything on that computer. And then realistically, if you were going to really cause trouble, which I'm not going to demonstrate this, you might install the reverse shell as a Linux service using systemd or whatever operating system they're using. You'd create a Linux service, and then you'd delete your other reverse shell so that there's no record of it in Kubernetes anymore. Now it's just running in the parent Linux operating system, and then you just start exploiting from there. So container breakout. So I've got the reverse shell. This is a Perl script, which I have handy. I said, well, let's go back to our list. I'm getting ahead of myself. Install the reverse shell, done. Install the text editor, so let's do that. So I'm going to, I have a command apt get update and %& apt get install -y vim. This will install vim for me, hopefully. You never know with these live demos. Things sometimes don't work right the first time or at all, but it seems like it's working. So here I'm installing applications now on that computer or in this container. Normally, it's worth noting you don't have privileges to do this, but I was able to run as root, which we'll talk about later how to prevent this, but the root user can install things. So now I'm running, I have Vim. I will mention that in a reverse shell, Vim is very awkward to use. So if you do want to do this, you actually have to have all the commands memorized because you're basically having to do this without the normal Vim user interface. I'm going to run a Perl script. So first I have to switch to my home directory, and then I'm going to actually create my Perl script. So I'm going to call it breakout.perl or PL for Perl. Switch to input mode, paste my file, exit and save. And now there's my file, and I can see, oh, there's my file. So there's my script. And to run that breakout script, all I do is Perl breakout.pl, and this will run my breakout script, which will effectively, if we look at that script, I don't know how deep I want to go into this script. There's a bunch of Perl mumbo jumbo, and if you've ever used Perl, you know it's a terrible, terrible language to use. But at its most basic level, what it's doing is it's basically running the system ch root command to go up a directory until it hits the parent root folder. I got this from Pentest Monkey. I learned Perl a long time ago, and I'm glad to have never had to write Perl since. So let's see if it works. It's running. It worked when I tried it before I did the demo. We'll see if it works this time. It works. I get no feedback, but it does work. If you wanted to check that it actually worked, I'm going to try to find a file that I know wouldn't be present in Ubuntu. So if I do find/grep Kubernetes, you'll see evidence that I can actually see everything. Or if I do ps-aux, I can see more than let's see, sudo ps. I can see more than I should be able to see. So I can see things that I shouldn't be able to see, and they're in the wrong places and things, right? So, okay. So that's container breakout. All right. So this ends the demo portion. This is a beginner level demo on causing trouble in Kubernetes, but I think it demonstrates some things, right? So let me go back to this 4 C's slide. It demonstrates that you do need to think critically about Kubernetes security. Just because it's in a container doesn't mean that it's secure. And just because, okay, there's a question, will we be able to download a recording? Yes, we'll post a message after this with a link to the recording. Great question you've been shown. So just because you are using Kubernetes doesn't make it automatically secure. You need to control what people can deploy, and you need to track what's being deployed. And you probably shouldn't use Docker, which we'll talk about in a minute. So what are some tips? Well, if you're watching this and you want to take something back to your team, I recommend take a screenshot of this. I'm going to leave this up for a bit because I'm going to be talking to these points. But take a screenshot of this, bring it back to your team, because this is a list of the best practices to avoid trouble in Kubernetes. So first thing to do, don't use Docker anymore. So if you're using a more modern version of Kubernetes, you can use containerd. In fact, it's the default now. It's not quite as intuitive if you're digging into issues on the server, but it's much more secure. As you can see with Docker, anyone who can basically connect to Docker on the server can basically do anything they want on the server. So do not use Docker. in production at least. Second thing, secure the Kubernetes API. Here's some really basic things you can do. So by default, Kubernetes allows anonymous login from an anonymous user group, which means that by default, if you're not paying attention, depending on what version of Kubernetes you're using, you might actually be allowing anybody to connect and execute commands against Kubernetes. I don't, maybe even deploying things, it depends. At the very least, they can see what version you're running. And if there are known vulnerabilities, it would be very easy for them to exploit those. So definitely disable the default anonymous user login. Second, firewall it. Don't let people just connect to the Kubernetes API. I mentioned Kubernetes is an API, and like anything, that means you can connect to it. And if you can connect to it, you can execute commands. And if there's vulnerabilities, you're vulnerable. So firewall it off. Don't make it accessible through anything but maybe a VPN or at least an IP whitelist. It just dramatically reduces your attack surface. Third thing, limit user privileges, including those of your developers. So most developers should not have access to deploy absolutely anything they want. There are ways to put constraints on what they can deploy. You can make sure that perhaps they can only deploy images that they've actually created and not images from Docker Hub. You might limit their ability to deploy as root or deploy things that can escalate their privileges. I'll cover in a minute how to prevent that. Can this be a finding now during security audits if we see Docker in prod environments at a client? Blesson asks. Yes, it might be. We're going to cover a tool that has best practices for Kubernetes that has the Center for Information Security's best practices. And I expect in the coming versions, Kubernetes 1.22 and newer, the CIS benchmarks are probably going to not allow Docker anymore. You can still use Docker to build your containers, your container images. It's just purely a deployment detail that when you're setting up Kubernetes, you can go a layer deeper. So that's a good question. Oh yeah, network policies. We are going to cover that. That's a great point, Ishmael. Okay. Limit user privileges. Disable auto mounting of default service accounts. So service accounts basically allow an application to connect to Kubernetes that is running from within Kubernetes. By default, there is a service account mounted called default that has some degree of read-only privileges in Kubernetes, such as picking up your Kubernetes version and sometimes even seeing what else is running. The problem with that is that if a hacker was able to do a reverse shell, even if it was non-privileged, if there was a vulnerability in Kubernetes or if they could see other things running around them, they could cause a lot of trouble. We're also going to talk about network policies. I think somebody mentioned just a minute ago to prevent them from being able to look around, basically. Use Kubernetes security context features. So Kubernetes makes it actually really easy to prevent things from running with escalated privileges. So they have a option literally to just disable running as privileged and disable running as root. You can have a toggle to prevent apps from escalating privileges. You can take away apps' ability to write to disk at all. So that just makes things dramatically harder. You can limit their Linux privileges. So you can use things like SE Linux and AppArmor to basically give them basically no privileges. I think by default, Docker already has some that are pretty limited, but you can take away more. Root users bypass it all. So make sure you don't let them run as root. And make sure you use something like Gatekeeper or OPA to actually make sure that your own development team is not running things as root, because it's quite easy. It's quite easy for, Bashir. So it's quite easy for developers to deploy things as root, and it's also very easy for you to just prevent that outright. Now I'm going to demo a few tools in a minute here, but I see a few questions in the chat. Let's see. So just a question in this example, user was root, but what if the user was non-root? Can privilege escalation be very easily done? Good question. So there have been several major Linux vulnerabilities. So if you're running an older version of the Linux kernel, there are several major vulnerabilities available that actually allow a user to escalate to being a root. If you're keeping your servers patched, it's not an issue, but if not, that's a potential issue. The other issue is if you don't disable sticky bits. So they have there's one of the security context options is to disable escalating and privileges. You can actually, in your Docker image, somebody might be able to put in a file that is a shell script that has the sticky bit set to allow that script to escalate itself. And if you're not careful, somebody could download that file off the internet or whatever, set that sticky bit to true, and escalate the privileges. Again, if you're just limiting the privileges, that really limits it. There are also some other techniques. If you're really afraid of like even Linux kernel vulnerabilities, you could use things like gvisor or Kata containers, where it'll actually boot up a VM for each container, where gvisor basically analyzes every single kernel call and will stop suspicious kernel calls just by Google. So, all right. So Trivy, I'm going to go through a few different tools here. Let me show you a couple. So first one is called Trivy. And Trivy is there's a good little animated GIF here. It's a tool made by Aquasec that's very nice. It will make sure that your application does not have any obvious security vulnerabilities. It does this by looking at what's running. It looks at all the packages and all the libraries you depend upon, whether it's operating system packages or code libraries. It compares them with some of the government security databases and just basically will tell you, hey, this package that you're deploying has a major vulnerability. We do this. So at our company, we use a tool called Minesweeper, which this is my baby. We actually kind of built this, but basically what it does is it will automatically scan every single image deployed to your cluster. It's a freemium product, so I encourage you to try it out. But for example, I can look at one here, which is the one built in the Cube proxy, and it actually is pretty good here. Let me find a different one. Okay, here's one. This is our own app. So it'll scan what's running, and it will actually tell you like, hey, there's a library you're using and it's out of date. You should upgrade the library because there's a known vulnerability here. So it's very helpful. Trivy is very easy to use. You can build it into pipelines, or like I said, we built our own tool around Trivy that that basically does the same thing. And Trivy is really nice for just making sure your code and the libraries being deployed do not have obvious vulnerabilities. It doesn't preempt your code from having bugs that would be vulnerabilities, but it will reduce your attack surface. So the reason it's really nice is a lot of hackers will use automated tools to do security hacking. And so if they can see, hey, you're running an old version of curl, or you're running an old version of Java, or you're running Java, and so the probability of you having an old version of the XML parser that has a known issue is pretty high, they can run automated exploits against your application. So in the same way that they can run automated exploits, you can automatically scan to make sure that those automated exploits are simply unavailable to them. So it's a smart thing to do. And again, you can use tools like this. There's a lot of them out there that will basically scan, and you can set rules that say things like, if there's a fixable vulnerability, don't let it deploy. So great tool. Before I continue, I see a couple other questions. Often we use a base image and run further commands to build image with entry point of our code. How these base images are created. So yeah, good question. So it's a base image like the Ubuntu image on Docker Hub. You'll find that the Ubuntu Docker Hub image is actually, let me show you. It's open source, but you can actually view the image, the Docker file itself. And you'll see every one of these base images starts with Scratch, which is literally in the second question here is from Scratch. Scratch is literally an image with nothing in it. Think of it as an empty folder. And then they copy in all of the operating system command line utilities, because really what makes an operating system is the command line utilities. So they'll literally unzip a certain version of all of the Ubuntu command line utilities, and they'll say that when the app boots up, it's going to run a shell. And so that's your base image. So if you say, I want to build an image from Ubuntu, it's starting off with an image with one layer, which is this one here, which is just all of the Ubuntu command line utilities that are included with whatever version of Ubuntu that I'm running. If I have another base image, like a lot of people might be using .NET, for example, Microsoft has a .NET image. And similarly, if I can find the Microsoft .NET Core image, here it is, .NET Core 3.NET. If I find the official one, okay, this is not the official one. If I was to find the official one, I could look at that and I could actually look through the Docker file and figure out what files are being copied in. If I use Alpine, the Alpine base image, it's just copies in the Alpine operating system utilities. So that's how that works. All right, so in building from scratch, somebody here asked about building from scratch. So certain technologies are very easy to package up. So if you were to write code in Go, or you were to use Java and use something like raw VM, you could package up your entire application into just a few files. And then you could actually say, you could create a Docker file that's from scratch, and then just copies in your compiled code and nothing else. And then there is no shell. There's not even a shell. We call these scratch images. And so there's no shell. And so how can you execute a reverse shell when there is no shell, right? So it reduces your attack surface. And things to think about. All right, so Trivy, that's one tool. Kubench, I mentioned the Center for Information Security's benchmarks. I expect that, well, every Kubernetes security audit should be using the official CIS utility or Kubench to check that they are compliant with the Center for Information Security's best practices. They do things like making sure you have unencrypted traffic disabled, making sure you have role-based access control enabled. I don't know if you knew this, by default, Kubernetes doesn't necessarily even enable role-based access control. So by default, the anonymous user can do anything, right? They'll make sure that you don't have an anonymous user anymore. And this is a utility that will scan, I think they've got a, yeah, it'll scan, let me see if I can scroll down. Okay. It'll scan and generate a report of every single potential vulnerability or issue that you have available, and it gives you instructions on how to repair every single issue. It's a great tool. I recommend checking it out. Swing back, okay. All right, let's see. Okay, hold on. The tool's not letting me click on things. We actually, I'm showing you here. I'll show you an example of one. So if I go to Kubench here, you can see I can click on a report. This one ran against the cluster, against the worker node, and I can see the result of that. And it has, we passed most of them. So we passed the worker node config files, great, thumbs up. And we passed the kubelet config. We have one warning, ensure that rotate certificate arguments is set to true. So it's wanting me to rotate my encryption certificates. Now it's worth noting that in this case, if you use an off-the-shelf tool like Google Kubernetes Service, Elastic Kubernetes Service, or there's one that, I forget the name of the one that, obviously there's Azure Kubernetes Service, but there's one that is used on premise a lot, but you could use Rancher too, right? If you use any of these tools, sometimes they don't give you access to fully audit them. They don't give you access to the master nodes. So there are different profiles you can use. We've made it really easy, and you can feel free to use our Helm charts and stuff. It's open sourced. But if you go to select your Kubernetes environment, if I was to pick Azure Kubernetes Service, we've made it so that you can run it on a like cron job. We just run them daily, honestly. They're not that heavy to run. So why not just run the report, why not run a security audit every single day, right? So we run it every day, and then we take those results, and you can see here in our demo environment, we boot one up every day. And you can see over time pretty easily if it's getting worse for some reason. Kube Hunter is the next one I want to show you. Kube Hunter, another great tool. Similar to Kubench architecturally, what it actually does when you run it is it actually runs in, oh, Tanzu, thanks Ismail. Tanzu is the one by, oh, what's the name? It's the on-premise tool, I'm totally blanking. VMware, thank you. No pressure. Great tool. So Kube Hunter, this runs a kind of a penetration test that actually will run as a pod in Kubernetes, and then it will try to see what it can see. So it'll try to use the Kubernetes APIs, it'll do some port scanning kinds of things to try to see what can I find out that I probably shouldn't. And then it'll produce a report for you. It's a really good tool, also open source. I'll just give you an example of a report. Again, we created a Helm chart for you that lets you install it with essentially a one-liner. You can just configure how often, hit go, and voila, you got yourself a daily Kube Hunter, a daily penetration test. And you can see here, if you run the test, it'll give you output very similar to the other one. Severity, high, medium, low. Here it's complaining that I have too much Azure metadata exposed. Oops, I should probably secure that. That would allow a hacker to scan and find more information about the cluster. It produces other reports too. It's good. It's a good tool. All right, next tool. KubeSec. So KubeSec will look at your deployments and tell you if you're doing bad things, like running as root. So it is not a preemptive tool, but it is a good tool to test whether or not you are doing things well. You can run it from the command line. They have a website API you can call. You basically provide it with a pod spec or the definition of an application you're going to run in Kubernetes. And I'm going to pick something that I know is going to get in trouble. I'm going to pick something that's part of Kube system if it'll let me. Here we go, Core DNS. Core DNS, obviously part of Kubernetes. If I was deploying a user space application with the same permissions as Core DNS, chances are I'm going to get penalized. Hey, it actually didn't do too bad, but it'll scan it and it'll look and say, well, does it have too much access, right? Let me pick a different one. Cert Manager. Let's see how Cert Manager does. Pretty good, actually. Cert Manager does pretty good. So it'll give you advice and it'll give you a score. So, and we kind of color code it at the top. It is mediocre, right? Now these tools obviously need more access. Is it safe to run an active mode Kube Hunter? They do not recommend running Kube Hunter in active mode in a production environment. By default, our setup here runs in passive mode where it just scans, it does not execute. But yeah, that's a good question. All right, next one. Security contexts. I did mention this before, but the basic idea with Kubernetes security context, let me give you an example, zoom in. Simply to tell it, hey, run as a non-production, run as non-root. Don't give it access to the file system. It has other, let me find the privileged flag if they have it in. I don't know if I'm gonna find a good example on their website here. I wasn't gonna demonstrate every one, but it allows you to define what user it runs in. You can give it read-only file system access, make sure it's unprivileged. Definitely worth using that. Network policies allow you to effectively set up firewalls in Kubernetes, such as not allowing horizontal or vertical traffic. So a best practice might be to not allow pods to talk to one another unless you explicitly allow it. So there's very easy ways of setting up a kind of global ingress and egress policy that limits pods' ability to talk to absolutely everything. You might just whitelist certain things on the internet or whitelist certain services that can access it. Benefit being that if somebody was able to launch a reverse shell or hack into something, they wouldn't be able to go anywhere, right? They couldn't port scan, they couldn't do anything because there's nothing to scan, they can't connect to anything. And then finally, Gatekeeper. So Gatekeeper has the ability for you to set rules for deployments. So you can say, for example, I do not want to allow things to run as root. I do not want to give things write access to the file system. And so we've got a tool here. You can do it from the command line. I like this tool because it's really visual. So there are some open source libraries and charts that have all of the built-in security context features where it allows you to enforce that people do certain things. So I might say, for example, I'm going to require them to use AppArmor, right? If I was to do that now, I could then click in here and I could say, I'm going to require them to use my insecure container only. I could require them to use my insecure container AppArmor policy where I won't allow it to deploy. I might allow, obviously, Kube system and things to deploy. And then I could save it and I could effectively, let's see, put a description. This would only allow things to deploy then using the, if they have the AppArmor profile. And AppArmor, again, allows you to limit Linux privileges. That's one example. I could go all day long with the different things you could do, but we, again, Gatekeeper is really easy to use. I recommend trying it. Again, we produce this tool for our use, and it's open for anyone to use. So try it out. It's how we make sure that our clusters are secure. But these tools are all open source, so you can try every one of these tools out on your own, and get a good idea. But taken together, if I'm going to just go back to my presentation here, again, it's all about making sure it's all about the basics, right? Run Kubebench. Fix everything, fix every issue that's being run. Don't deploy software that has major vulnerabilities, and limit your software's access in Kubernetes. If you do these things, 99% of your attack surface is gone, right? So I think that kind of covers the core of this presentation. So yes, yeah, Ishmael says, nice, getting me away from writing Rego. Yeah, that's the idea. If you go to the Minesweeper website, there's a quote about Rego. If you've never touched it, it's probably the worst programming language ever invented. In any case, that kind of concludes the core of the presentation. I want to open it up at this point to any questions that anybody might have. me just check. VMware tends to OpenShift. Yeah, OpenShift's a great product. That's good. Oh yeah, somebody says there's a tool. Yeah, so if you go to minesweeper.io, you can try the same tool that I was using in this presentation. Great tool. It has an install wizard that takes about 3 to 5 minutes. They have an example of installing it here. It installs pretty quick. It actually runs in a Kubernetes cluster. It's very lightweight. The other thing I think that's worth mentioning, I've got a copy of this presentation up at jackkubernetesup.com. So kind of a fun website. So definitely check out the website, share it with your friends. I'll be putting more content on the site. You'll see a recording of this presentation going there. So share it out with your team. Let me know if you have questions or feedback, comment on the post, whatever. But we're going to be putting together more materials. I have links to all the different tools that I linked in the presentation under countermeasures. So again, try them out. At the very least, run Kubebench and Trivia and make sure that you haven't made any major missteps. At the very most, automate these things to run daily. So great. Let's see. Okay, here's another question. How does your Minesweeper product compare to ones like Aquasec or Prisma Cloud, aka Twistlock? Does your sweeper app integrate into CI/CD pipelines? Yes. So I would say that we're very similar. A few differences. So we made a few noticeable differences when we built it. First, our product doesn't require, it's not as heavy. So it's much less likely to break your system. Things like Twistlock and Aquasec actually install applications that run on your servers and are very controlling. And if there's any interruption of their application, it can take your whole cluster offline. So we wrote ours to be much more lightweight and much less likely to accidentally break your cluster. Second thing, we cover more things. So a lot of these tools are very narrow, like they just mainly do vulnerability scanning. They don't necessarily do all the other pieces. So we tried to make ours really broad and really lightweight and quick to install. So that's the big difference. But yeah, it's comparable to those tools. Does it integrate with a CI/CD pipeline? So a little background. CI/CD stands for continuous integration and continuous delivery. And the question there is about every time that you compile and deploy your code, can you also trigger a scan at that point instead of waiting for Minesweeper to scan it? And the answer is absolutely. We have a command line utility you can use in a pipeline for that exact purpose. You point it at an image and it will scan it and upload the results. We have the ability to prevent things that are unscanned from deploying, as well as to block things from deploying that don't meet your security credentials or your security requirements. We also have a whole exception management feature. So it's very comparable to Aqua and Twistlock. It's lighter weight, it's easier to use. We honestly have used those products. We've implemented them for clients. We tried to make it easier than those tools and lighter weight. And under the hood, it's a lot of open source tools. So it's it's a little bit more open and a little less magic. Any plans to add more tools? Yes, we have more we want to do. The next big one we're looking at is actually taking Project Falco, which is another good one. I should probably add this, but let me just show you this one. This will be a Q1 feature. But what the Falco project can do is it can listen into your applications while they're running. It's created by Sysdig. It's really good. They've got a similar product. What Falco can do is it can look at what your application is doing and every Linux call it makes, and anything that's suspicious, like a port scan or starting a new command shell, it could then alert. And the thing is, though, Falco doesn't give you any of the alerting mechanisms. So it basically just kicks up logs, and then you've got to build out those alerts, right? So what we've done, or what we will be doing Q1 of next year, is we will be basically having an installer to install Falco for you, and then it will basically take those alerts and allow you to filter email, do some, I call it anomaly detection, but really it's just the first time something happens every day, we'll let you know about it and give you a summary email every day so that you can detect if there is a threat. So you can detect if someone has broken into your cluster, as well as just generally tune the rules so that they're actually useful for you. So kind of like every one of these tools, we're just trying to make Kubernetes security be like easy mode, right? So, and every one of these tools is open source. So if you don't like us, you can just go use the open source tool. They're great. You should definitely be using one of these tools. What cost tiers are available for using Minesweeper for Enterprise? So we have basically 2 tiers. I'm not gonna, if you want to use it, just reach out to that form on our website. This is really just an educational presentation. I don't want to be pitching Minesweeper too much, but reach out to the form on the site. It's a freemium model, so you can use most of the features. Basically, the paid tier is some of the more advanced exception management and enforcement rules. That's the big difference. Let's see, what else? Besides explicitly writing an OPA policy to check for non-root users, were any of the tools available to check a container runtime configuration, aka checking for non-root user? Yes, so good question. So let me think. So that question, I guess, would be, so whenever an application boots up, it runs as the certain user account, right? And so the OPA policy that we use in here allows you to specify that the user ID has to be not just greater than 0, but greater than 1,000 or greater than even 50,000. The idea being that there may be other Linux services on the computer that are non-root, but still have escalated privileges. And so that OPA policy will require that initial user to be higher. And then there's another Linux privilege to switch which user account you are currently using. And so if you turn off the escalate privilege feature in the Kubernetes security context, or you use something like SE Linux to do that, or seccomp, you can prevent the pod from ever changing which user account it runs as. So then you can make sure it runs as a high level user that's unique and prevent it from ever changing which user account it runs as. That's kind of what you'd want to do. That's how you'd make it actually work right. And that would make it so that it's pretty foolproof. But yes, so that kind of concludes the presentation. I hope you've learned a lot. I hope I didn't talk too fast. I get excited sometimes, and I'm prone to that. So, but I'll stick around. We got 5 more minutes. If there's any other questions, I'll stick around. But feel free to drop again. Share the website. I'm going to be putting this site up. It's jackkubernetesUp.com, and we'll have the video up there after this presentation. Definitely check it out. Share it with others. As we add more, I kind of plan on putting a bit of a like a quick reference to a lot of different tools and tips and tricks that we'll be putting together over the coming months, showing you each of these different tools in more depth. We plan on doing one of these a month for at least the next 6 months. And we haven't decided what the next one will be, but it will be in early December, so before the holidays. It's probably going to be related to, probably going to be a deep dive into like Kubench, possibly taking a Kubernetes cluster that's been booted up from nothing, and then fixing all the Kubernetes Kubench vulnerabilities from 0. But I haven't decided yet. If you have any ideas or anything you want to know, just private message me on LinkedIn. I'd love to know. I'd love ideas. I'm not too married to any particular topic though, but I'll try to keep it interesting. It's not going to be boring. Like this one, I think was pretty interesting. And in subsequent ones will similarly be very interesting. So wonderful. Well, thanks everybody. I'll stick around, and if I see any questions, I'll go ahead and respond. And yeah, no problem, J.R. Bullington. Glad I could answer any questions you have. Yeah, no problem, Ryan. It's good. I'm glad you enjoyed it. I've got a question for you guys. How was the LinkedIn thing? Was LinkedIn a good way to do it? Were there any confusion in the setup or the sending out of the links? Anything I could do differently there? Yeah, no problem, Pankaj. I'm glad you enjoyed it. Yeah, Jared Bullington says LinkedIn was helpful. Great. Yeah, how did you guys find it? Was it all LinkedIn? We had a lot of people sign up. Okay, messages from LinkedIn worked great. Good, I'm glad. Reddit. Hey, Reddit, awesome. Good, I'm glad that worked. We did post it on Reddit. We'll probably post the video too, we'll see. Maybe when we'll get some Reddit love. Hey, glad you enjoyed it, Nemanith. Yes, time zone. So that was one thing somebody brought up, was the time zone is not convenient. We had a lot of people interested from Asia. And so we might be doing the next one in the morning. We'll see. We'll probably switch it up. So if it was morning US time, that would be late afternoon or early evening in India, Bangladesh, and Pakistan. So we might be switching the time to make it more convenient. But yeah, this time's also okay in Europe. So we've kind of been, I think we had people from 10 different 10 different countries sign up. So we're going to be experimenting. Yeah, 10:30, 2:30 in the morning. Yeah, I know. So well, the next one will be more convenient, and we'll be sending out a recording as well. So great. Wonderful. Well, I think we're at about the time, so I appreciate everyone joining. And you guys have a good evening, morning, and afternoon. We'll talk to you later.